Okay, now that Cheshov has kind of given an overview of what Morpheus is, I'm going to go through how it is implemented and how successful it actually is. So the paper talks about how it was implemented as an extension of Apache Hadoop and Yarn. And to do this, to accomplish this, they actually had to rework, make some significant changes to the resource manager that Yarn has. To enable it to scale, to enable Morpheus to scale. And I won't go into all the details of exactly how they had to, but just at a high level, the changes they made introduced some small and transient inconsistencies, they said, which were able to be resolved within milliseconds. And that, but the change they made also increased scalability by orders of magnitude. So how does Morpheus do? Well, they tested it on an enterprise trace with that had millions of periodic job instances in it, and so they simulated Morpheus on it, and they found that for approximately 70% of the SLOs, the service level objectives that they derived from this data, the probability that and I guess to clarify here what B and A are, A is a job that comes before B. In other words, B represents a job that depends on the output of A. So given that setup here, they found that the probability that your job B would fail, given that A had missed its SLO, was approximately equal to the probability that B would fail given that A failed. In other words, it was greater than 4 times the probability that B would fail if A had met its SLO. And just to give a high-level overview of that, what it's saying is, what this equation says here is that if A met its SLO, it was much more likely that B would succeed than if A had missed its SLO. It was 4 times more likely. And that is what shows that Morpheus is doing a good job of deriving these SLOs, because an SLO should be exactly that. It should be a predictor of what you need or expect or want from your job, your periodic job instance. And then here are some tables down here that kind of show what Morpheus was able to accomplish on this enterprise trace. A nearly 13 times reduction in SLO violations. And remember, we've already established that the SLOs are good indicators of what the user wants out of their jobs. So given that now there's a 13 times reduction through Morpheus of violations of those SLOs, that's extremely good. Also, in terms of job provisioning, right? How many resources are being provisioned for each job? This light gray line here represents the user provisioning, kind of like the automatic user provisioning, and then these lines over here represent what Morpheus provisioned based on different alpha values, just parameters that they set for Morpheus. And this dashed line here represents the ideal amount that should be provisioned, what the job actually needs. So if you'll notice, Morpheus does a much better, much tighter job of estimating and provisioning resources than the user does. Much better job. And then the paper talks about some scale tests that they were able to do. So on a 275 node cluster, Morpheus was able to eliminate sharing induced variability and meet target SLOs for the most part. Bumping that up to a 2700 node cluster, Morpheus was able to sustain the load. And then finally on a 4000 node production cluster, Morpheus did a pretty good job, but the paper does note that there were some utilization swings of more than 69,000 cores during the job execution. So, to me that indicates there could be problems with scaling Morpheus, but on the whole it did a pretty good job. So, I mean, the question, does Morpheus work? Yes, it absolutely does, but there are potential scalability problems with it. Um, so you're probably wondering, right? Do other solutions exist? How novel or innovative is Morpheus really in accomplishing these things? Well, the paper does a good job, I think, of mentioning these other solutions that are out there that accomplish different parts of what Morpheus does. For example, this solution called Press. Um, that is a tool that does enable meeting SLOs at a single node level and dynamic allocation. So you see how Morpheus is able to do more than this, right? It's not just at a single node level. Morpheus is able to accomplish this at a cluster level, essentially. But the dynamic allocation is there here. Jockey, similarly, dynamic reprovisioning. They have a method for implementing dynamic reprovisioning. And then there's others they mentioned: Mesos, Borg, Omega, Apollo. I won't go into the details of each of these, but essentially they each have pieces of the Morpheus solution, whether it's the job packing or the deriving SLOs or the dynamic reprovisioning, etc., etc. So what exactly is the novel contribution of Morpheus? Well, it is it is the first tool, the authors claim, to provide fully automated, framework agnostic SLO derivation purely based on history. So what does that mean, right? In other words, other tools have ways of deriving SLOs, but not based on the history of the job performance in that cluster. And also, they are often framework-specific methods, and they're not fully automated. They're semi-automated. So that's what's unique about that's what's completely novel and unique about Morpheus. And you might read that and say, huh, that's not quite as impressive as I was expecting. And I would agree. I don't think this is quite as impressive as the paper would seem to be indicating about Morpheus, but it is still quite a significant achievement, I would say. And also, I mean, in addition to this being completely novel, it also combines a number of elements from these previous solutions that we talked about into a nice cohesive whole that accomplishes quite a bit. So, I mean, our conclusion is that Morpheus is a practical solution. It's not just a theoretical concept. It is a very practical solution for achieving both predictability and efficient cloud utilization. And it can also... what can it do, right? What can Morpheus do? First, it can automatically derive accurate service level objectives, right? We showed they were kind of able to validate and prove that the SLOs it's deriving, those service level objectives, are accurate, right? They do indicate how the job should perform, the deadline that it should perform by, the kind of the number of resources that it should consume, the limit on them that it should have. That's number one. Number two is Morpheus can reduce the violations of these SLOs that it derives by approximately 13 times, which is very significant. Number three, it can reduce the required cluster provisioning by approximately 16%. So not only is it, it would be easy to reduce these SLO violations if it just, decided if it was just making the cluster consume more resources for these jobs, but it's actually both reducing the violations and, in doing that, reducing the required cluster provisioning by a significant amount here. And I can somewhat reliably scale to massive production size clusters. I say the somewhat because, as we saw, there was that kind of there were those utilization swings that we noticed when it went to the 4,000K production node clusters. And our conclusions are, yes, the paper was very well organized. It was thorough. It kind of addressed, other contributions. It addressed the motivation. It addressed the solution that it was able to implement fairly well. And what we learned was the dichotomy between the predictability and the utilization requirements of the user, the nature and necessity of SLOs. In other words, what they are, how they're necessary and useful, and also, depending on where this goes, where Morpheus goes, we also learned about the potential future of enterprise clusters. So thank you. We hope you enjoyed it, and feel free to post any comments in the discussion post.